we are going to be continuing with our first section. Hopefully we'll get this finished today and we can move on to the next one. It's pretty mundane stuff. It's kind of number crunching, aren't we? Right now, aren't we just looking at how do you turn degrees into radians or radians into degrees? And each one of them has a formula. Okay, suppose I want to turn degrees into radians. Any volunteers for the formula? I want to turn degrees into radians. So how do you do it?
Radians equals degrees over 180 times pi.
We all happy with that? Unless the answer says to 3 decimal places, won't your answer be 7/9 pi and 3/5 pi, right? If it says to 3 decimal places, don't you just hit buttons in your calculator and say 0.123? If you go the other way then, what is the formula for turning things into degrees, right? So I give you it in radians, but I want the answer in degrees.
For degrees, it's 180 times the radians divided by pi.
Okay. In that situation there, won't your answer be basically the calculator? So if it's a nice number, the calculator tells you it's 21. And if it's a horrible number, won't it tell you it's 21.234? You could get a fraction, I guess. You know, sometimes you could get, 7/9, but more than likely it's not. So we have covered that process at least a little bit. Let's now delve into some of the more interesting or unusual versions of using that. Let's look at negative angles. Now, the normal way, whether it's radians or degrees, it doesn't matter. We measure angles by always starting on the x-axis, right? That's our first arm. And don't we normally go in an anti-clockwise direction to get our second one, right? But if someone wanted to, for instance, do a negative 60 degrees, it would be down here. And it would be going, strangely enough, clockwise by 60 degrees. Great. So if positive angles go anti-clockwise, doesn't it seem reasonable that negative angles just means you go clockwise? It's sort of a counterintuitive. Wouldn't you have thought that it should be the other way around? But, it is what it is. There are reasons why we measure angles in that weird anti-clockwise direction, right? There are reasons for it. We just have to assume that there's a good reason for it. But I still want to know what these are in terms of radians. Would it seem reasonable then that a negative 60 degrees should also be a negative number of radians? Would that seem reasonable? And would it also seem reasonable that the formula that we've got should still be useful? In other words, we should be able to use it to get the answer. And the good news is that we do. So if I wanted to turn negative 60 degrees into radians, it would be negative 60 over 180 pi. And if it simplifies as this one does, wouldn't it be negative 1/3 pi? Or for those people who like that, negative pi over 3. Oh, so would you agree that's not a biggie then, right? Can't we find negative angles and turn them into radians and degrees, and we can do positive angles and turn them into radians and degrees, right? Isn't it the same formula? Just your answer is going to be negative. How about turning a negative radian into degrees? So suppose I had negative 3/8 pi, right? That's radians. And I would like to know how many degrees it is. Well, it's going to be 180 times radians all over pi. And I guess if I was on top of my game, I could do that by hand, but I'm not. It's 180 times negative 3 pi divided by 8. That's how you type in negative 3x pi. That's the top bit, right? And then divide by another pi. And the answer, oh yeah, did I hit the bracket wrong? What did I do wrong there? Let me check that again. Oh, I know what I did. I'll show you what I did because it's so easy to do. Actually, good teaching moment, this mistake. When you look at those two calculations, if you look at them superficially, doesn't it look like they're exactly the same thing? Do you notice that the bottom one has a slightly smaller looking negative sign than the top one? Do you know the first time, didn't I hit the subtract button when I should have hit the negative button? That's why I got the error. Now when I hit the answer, do you see I've got a nice number? Negative 67.5. It's such a careless mistake, but you know, everybody does them from time to time. Have you ever done it yourself when you should have said negative and you hit the subtract button? So now that we know the answer, we can type it in. The calculator is pretty unforgiving. It just says error. It doesn't tell you what you did wrong. It just says, hey, this isn't sensible. I know I've only done 2 examples of this, but would you agree that negative angles are no different than positive angles? You do the same formula, you get the same kind of answer. So unless you want me to, I don't think I need to dwell on doing more of these. Are you comfortable with saying one of each and call it good? I'm saying nods, so I'm going for it. This is good. So now I want to look at, so that was negative angles. Now I want to look at angles bigger than 360 degrees. Or in radians, angles that are bigger than 2 pi. Well, let's see what that might look like. Suppose I was going to do an angle of 400 degrees. Superficially, you might say, well, that's impossible. The most you can get is 360. Well, let's see if we can figure a way of making sense of this. I'm trying to use this here. There's 0, right? 90, 180, 270, 360. Right, so far, haven't I done 360? Well, if you want 400, don't you just go another 40 degrees worth? So if you want to do an angle of 400 degrees, can you see that what you do is you go all the way around and a bit more? And that's what 400 degrees looks like. Does that seem reasonable as of how to visualize it? So we're no longer thinking of angles as the gap between 2 arms. Aren't we thinking of angles more as something turning? That's actually a better way to think of angles, right? The amount that things turn. Now, if you want to take an angle that's bigger than 360, and you want to, as we do, because every single question so far wants to do that, aren't you going to turn them into radians? Will it surprise you to know it's the same formula? No, it shouldn't. So here we go. Radians should be degrees over 180 with the pi. And I'm trying to keep this as an exact value. So I'll do the trick on my calculator. I'll go 400 divided by 180. And then I'll do math button number 1. And I get, there's your answer. Now, suppose you wanted to do an angle that's bigger than 2 pi. Suppose you wanted to do 17 thirds pi. I'm not even going to bother trying to draw that one or show you, but would you agree it's bigger than 2 pi, right? Now, I want to turn it into degrees. So it's going to be 180, 17 thirds pi divided by pi. And do a little bracket. 180 times 17 pi divided by 6 divided by a pi. And the answer ends up being 510 degrees. So we've used this formula to do negative angles, right? Angles that are negative 30 degrees or negative half pies. Haven't we now used the same two formula for angles bigger than 360 or 2 pi?
I'm a little confused.
Yes.
Was it, it says 17 thirds, and on the other side you wrote 17
Oh,
six.
that's because I can't keep track of my questions. I've now made it 17.6, so it's 17.6 all the time.
Okay, that's why my numbers were wrong. Thank you.
Yeah, well. Oh, I should mention to you, you'll get used to this. I make mistakes. One of the reasons I make mistakes is I'm old. Another reason is I'm careless. And the third reason is I'm always thinking of what's coming next and not concentrating on the moment. So I do make mistakes like the one that was just noticed. Will you point them out? Because I'm totally okay with being told that, because other people are having the same issue. Oh, maybe you do have that number when you do these questions, and I just didn't hear him when he told me that, Rob. No, it was just a mistake. So whenever I do 2 times 3 and tell you it's 5, will you not say, well, he's been teaching for 42 years and he's got a couple of degrees. If he says 3 times 2 is 5, it's just a funny arithmetic I've never seen in my life before, and I'm writing it down. No, the answer is I can't count, and you will tell me, don't you mean 6? Right? That's the real answer, right? So be aware of that, because there may, and there has been, yesterday I probably made a mistake and nobody called me out on it, and so I don't know I've made it. And some of you are now going back and looking at your notes and saying, how come that 17.6 turned into a 17 thirds? Am I missing something here? No, I just wrote it down now, right? So you are totally, I want you to do it and to pick me up when I've done that. So big angles, we can do this conversion. Negative angles, we can do this. Normal angles, right, 0 to 360, we can do this. You might think we've covered every possibility. Well, we've kind of and kind of not. There's one more combination that we haven't done. Couldn't we have negative big angles? Right, bigger than 360, but also negative. And for that same matter, couldn't we have, I'll try and do this, couldn't we have negative big radians as well, right? Do you think I'm going to change the formula? No. Aren't we just going to, and since I've done it, I guess I need to do it for completeness sake, but aren't we just going to plug it in and plug and chug? So for this one here, it's going to be negative 1,000 over 180, tag a pi on it. So clear that out, negative 1,000 divided by 180, and then do a math thing on it, and it's negative 50/9. That was nice and quick. And for the second conversion, this fella here, we're going to do 180 times that fella divided by pi. Only this time I'm going to make sure I use a negative button. So it's 180 times negative 7 pi divided by 3. Okay, let's be careful here. I'm putting a bracket just to be safe. Yeah, that looks safer. It might not matter, but have you noticed I put the entire top with a bracket around it? So when I hit enter, we get a nice answer. Now, originally I was going to just do it this way, and it may still work. In other words, it's going to be the same answer. And it did. But have you ever done calculations where the order of calculation is important? And you need brackets to make sure that that happens. So when I'm not so sure if I need to worry about that or not, I stick brackets in things just to be safe. And we are finished with converting degrees to radians. Haven't we done every blinking thing you can think of to them? Right? Big and negative and all the other combinations. So let's look at what is called the standard position of an angle. The standard position of an angle is the angle that's always going to be between, let's do it in degrees, 0 to 360 degrees, that the original angle makes with the x-axis. Now, there isn't a formula per se for this, but let's suppose I give you an angle, and that angle, we'll do the one we did earlier, is 400 degrees. Remember that one? Now, if you want to know what its standard angle is, you start there, and then we go all the way around and a little bit more, and we finished up here, right? And I'll just put the 400 degrees there to make it easy to see. Wasn't that what 400 degrees looked like? Now, the guy that's called the standard position is the angle that it makes with the x-axis. Do you see it's that guy? So what's the standard angle, the standard position? Anybody want to tell me how big that angle is?
Would that be 40 degrees?
It would be. How would you do it as a calculation for me? You're correct.
Say that again?
How would you get from 400 degrees to 40 degrees? What was the calculation that you used? I mean, I'm pretty sure you did it in your head, but what was the calculation?
400 minus 360.
Yeah. Don't you basically just take away one circle's worth of degrees? Right. Does that make sense? Now, the reason there's not a formula for this is that the angles can be huge and there's no simple formula. So let me give you another angle. 700 degrees, and I'd like to know its standard angle, its standard position. What you do is you take away 360, and in this case, you're left with 340. And when you are left with an angle that's between 0 and 360, that's you finished. That's your standard position angle. Does that make sense? Now, if the angles get much bigger, let's suppose the angle was 1,000 degrees. You take away 306. Oops, there I go. You take away 360, and that leaves you with 640 degrees. But isn't 640 degrees still too big? So what do? You just take another circle, right? Another 360 away. And if you take 360 away from that, I'm not going to risk it with my brain. 640, take away 360, you finally get to 280. And when you reach that number, don't you know to stop? Does that make sense? How you find the standard position or the standard angle? You stop once you got that. Now, let's do it with radians. But you notice there's not a formula there. Isn't it really just a process? Now, I wouldn't even be writing half of this down normally. So let me show you that same calculation the way I would do it on my calculator. Okay, I'd go 1,000 and I'd take away 360. Too big. I'd take away 360. There we go. Isn't that kind of how you would really do it in real life? You wouldn't be writing all this down. But this is for your notes, right? This is so you can say, I wonder how you got that. So far, so good. Actually, I was going to do radians and I will, but I'm going to do some before that. You could also get really big negative angles, right? We got that one. And I still want to know what that standard position angle is. And I'm going to do this, well, I'll be writing the answer down here in a minute. I'm going to do this with my calculator. So negative 1200. What do you think I'm going to do this time that was a little bit similar, but also a little bit different from the previous question?
Add 360.
Right. And when I do it, no good. So what do I do? I'm getting there, but I'm not there, right? What do I do now?
Add another 360.
And shouldn't I keep doing it? Of course, I have to know when to stop. Does that look like I should be stopping? Be careful. Doesn't the standard position have to be between 0 and 360? Remember? It's over there somewhere. So negative numbers no good. So one more time. And now we've got our answer. Does that make sense, how to get the standard position? Now, if you're a bit of a gambling person, couldn't you say, well, I know 360 is not going to do it, so I'm going to take away 3 lots of 360, right? So imagine the original number was negative 1200, and I think I should be able to add 3 lots of 360. There. Can you see I'm almost there, and then one more 360 gets me to the answer. So if it's a really, really big number, couldn't you take away maybe 5 lots of 360 just to speed up the process, if you felt comfortable enough to do that? Otherwise, can't you just keep adding it till it works? Do you need to see another one of these? Are you pretty comfortable about the process? We are good. I like good. So now I promised you radians, and I should. Let's do something like 17 thirds pi. Now, I want to find out what its standard position, standard angle is. Well, when it was degrees and it was positive like this, didn't you just keep taking away 360s till you got what you wanted? Agreed? What do you think I'm going to do when it's radians then?
Take away 2 pi.
Agreed? So for notes, I'm going to do this. Now, for convenience on a calculator, it's probably a good idea to pretend the pi's aren't there. So what I'm going to do is 17 thirds, take away 2, and then turn that into a fraction. So that's what, 11 thirds. Are you happy about how I got the 11 thirds? Right. Okay, would you agree that's still too big? Doesn't it need to be between 0 and 2 pi? And believe me, that's 3 1/3. So I'm just going to take that, subtract 2, and then convert the answer into fractions, and I get 5 thirds pi. Is that in the range 0 to 2 pi? So won't that be the answer we were trying to find? Standard position. So far, so good. Anybody want to guess what my next question is going to look like?
Negative radians.
Yeah, negative and big. You have to do it both ways, right? So let's do negative 18. I don't know, 18 thirds. I'm just randomly picking things. Okay. What's the difference? How would we approach this one? I wouldn't take away 2 pi, so right? That wouldn't be a good idea.
Okay, add it this time.
We'll just add it this time. Right, I'll cut out the middleman and just do the answer to the end here, because I don't think it should take too long. So negative 18 thirds, add 2, and it should be a nice whole number. it's -4. And I'll add 2. And it's now -2 pi. And I'll add 2. And now it's 0. So actually, that guy is 0. You don't say 0 pi, there's no point. Now, the ones that I did were really nice numbers, right? They were whole numbers when it was degrees or nice versions of pi. But couldn't you do the exact same process with really ugly numbers, like 1013.2 degrees, right? Couldn't you keep adding, taking away 360 and it would work? So as long as you use your calculator, even ugly ones that don't come out nice, can't you still get the answer? So let's turn this question on its head.
Could I
Yes.
interrupt her?
Sure.
So on the last one, I don't think I was following properly, because when you got to -6/3 pi or in -2 pi.
Mhm.
Oh, never mind. We have to be positive. I get it.
Right. All
Thank you.
answers have to be 0 to 2 pi or 0 to 360. Right.
Right. Thank you.
Okay. So let's turn this question on its head. I'm going to give you a standard angle, right? A standard position. And this one, well, this one is a bit like question 7. And I'm going to give you 110 degrees. And you're being asked to find 2 positive angles and find 2 negative answers, negative angles, right? But they have to be in the range -720 all the way to +1080, right? So they can only be in that range. And they have to be equivalent to that one. So if you've got an angle at 110 degrees, right? So you went round and you got 110. If you wanted to get 2 positive angles and 2 negative angles, let's do the 2 positive ones, right? You take 110, wouldn't you add 360? Wouldn't that get you one of the angles that would end up having the same guy as 110? And if I wanted a second one, couldn't I just add on 2 lots of 360? I guess that's the short way of doing it. And that would be, what, 7, 830 degrees. And those fit in that range, so I know I'm fine. If I start with 110 now, but I want 2 negative answers, won't I take away a 360 and then take away another 360? If you take away 360, that gets me, I believe, -250. And this one gets you -7, -810. You should always check anything I do in my head in case I didn't do the calculation. So if I give you
The
question,
second one should be 610.
thank you. Did you all catch that deliberate mistake to see if Aaron was paying attention? Does anybody believe that was a deliberate mistake? If you did, I have a bridge I can sell you. That was just a mistake. But can you see how that would be helpful if someone else looked back at their notes and thought, where the heck did that 8 come from? Because it all makes sense. Okay. I'm going fast and getting all this down. So if I gave you any angle in degrees, do you feel you could get me a couple of angles that are positive and a couple of angles that are negative that would be equivalent to the 110 starting guy? Isn't it a bit like, I've gave you that and you're finding him, right? Or I've gave you this guy and you're finding him. Aren't we just changing the question, switching places? We're saying, okay, the standard angle is 110. You tell me a guy that's the same as it, right? Well, all the way around, another 360, right? All the way around, 2 lots of 360. If you want another one, all the way around and 3 lots of 360. Couldn't you go in that direction till you get bored? Are we good? Do you need to see another one of these on degrees, or are we calling it good? You feel comfortable? For completeness sake, I do have to do a radian one, even though it's pretty much the same question, right? So let's have a standard position. Let's say it's 2/3 pi, and we'll do 2 positive ones, and we'll do 2 negative ones. I don't need to worry about the range. They'll come out pretty straightforward. So if I wanted the 2 positive ones, what would I add to 2/3 pi?
2 pi.
2 pi. So 2 2/3 gets me 8/3 pi. And I think the other one would be 14/3 pi. And to get the 2 negative ones, wouldn't you subtract 2 pi? And so I believe the first one you get negative 4/3 pi, and the one after that you get negative 10/3 pi. Does that look good? Right. So there's a couple of questions where you are looking at that fella. I'm looking for something, if I can find one, just in case there's a permutation or a combination I've not covered. Because there should be some. No, I've done that. No, done that. No. Okay. I'm just, I know I'm pausing along because I haven't a clue what I'm doing here. Okay. Let's give you some names for these guys. Do you know these 4 guys here? They're called coterminal angles. So a coterminal angle is an angle that's the same as 110 degrees, right? It's just you went round the circle once to get there. So these are all examples of coterminal, and so are these. So suppose I gave you an example. God, my brain is going. Apologize. I'm scrolling through a thing that I can't see because the darn thing isn't letting me do it. Okay, where's it gone? I've lost my window. Right. Okay, click on it again. No, that's not the right window. You'd think after all these years I'd know how a window works, wouldn't you? Still not coming up. Okay, that's better. Okay, I'm going to show you now some of the homework questions just so we can get a look at them. Took me a while to find the darn thing, but we should be good. Right, so here is section 6.1. This is what our homework looks like. Oh, it seemed to remember me from last time. I think that was me, but didn't I put that in and it was wrong? Right, okay. Can you see these questions are kind of what we've done today? Turn radians into degrees, right? Turn degrees into radians. I've got my little dog bugging the heck out of me as well. Let's find some new stuff down the bottom. Okay. Yeah, it's pretty much the same kind of questions. There's a negative one. I think that one's normal. There's a negative one. That's pretty normal. What the heck is that? Oh, that was me just telling you how to hit the buttons. That's not an answer. Okay. Okay, here's an example. Do you see this question here? And it's asking you to find angles that are coterminal to someone, right? That's pretty much the as far as we got. So now I know where my brain is. Let's go back and look at some examples. Do you hear a lot of scratching? No? Come here, little girl. This is one of the reasons I'm being so distracted, although you can't see it. While I was trying to do my stuff, this young lady was all over, running around, and I was quite worried that she'd get into the cables. I've shown you my dog before. Have we shown you? Yes. She looks kind of cute right now, doesn't she? Yeah. Well, this little lady this morning tore up her pad and decided to poo on our carpet. So she is not in my good books. She thought it was funny because she loves tearing paper up. She thinks pads are toys, and kissing me doesn't get you out of trouble, young lady. So I'm going to put her in the cage so I can concentrate on my job. So you're going to have to stay there. There you go. Okay, how do you tell if two angles are essentially the same place? What do you think you might do?
You add or subtract 360 to them?
Okay, do you need to do it to both of these or just one of them?
Just one of them.
Right, so if I take 360 away from this, doesn't this guy end up being 50 degrees? So they are coterminal. And suppose I gave you 700 degrees and I don't know, 400 degrees. You're shaking your head, which I would agree, they're probably not coterminal. But to check, shouldn't we find out what they are as a basic angle? So if you take this guy and take 360 away, isn't T 40 degrees? And if you take 360 away from this one, I believe you get 340 degrees. Would you agree that they don't match? And so, are we good with these kinds of questions where I give you two guys and I ask you, are they coterminal? Since you get 5 shots, if it's not the first one, won't it be the second one? Because there's only 2 answers. Yes, it's coterminal, or no, it's not. So hopefully that bunch of questions will just kind of come out in the wash. I'm scrolling through in case there's others. If it was radians, wouldn't I just be taking away 2 pi's until I got an angle I wanted, or add 2 pi if they were negative? I think I should do another one of these. Let's do a negative one. Negative 30 degrees and 300 degrees, right? Are they coterminal? Well, that one's good. Can't I just leave him alone? What would this one be? Well, wouldn't you add 360 to it? And if you added 360, you end up with positive 330. So the answer is no, they're not. Can I skip by the radians? Won't the radian ones you just add 2 pi to get them to match, or take away 2 pi? And then if it's the same answer in both, you're good. And if it's not the same answer, don't you just say no? I feel I'm zooming by some of this, but I hope I'm zooming by because you know what's going on and you don't really want to waste time doing some obvious. Would that be fair? Are we good? Right, great, because that means we can finish our first section. And we can now move on to arc length and area of a sector, which is kind of cool. So let's start with arc length. Can you hear a squeak right now? She's really annoyed at me because I put her in her cage. So she's got her toy and she's deliberately squeaking at me. Should I let her out? Should we let her out of jail? Yeah, we'll let her age you. Come on. There. That's it. She's gave up squeaking her toy now because she got what she wanted. Okay. Imagine you have a circle, and we'll make it a very general circle, and its radius is r. On this circle, we'll have a curved bit of the circle, right? This little piece here, right? And that's called the arc. And right in here, we'll have an angle theta. And if you want to get the arc length, it seems strange, but the arc length, we use the letter S. Can't tell you why, because I don't know. But it's called the arc length. And it's equal to just r times theta. So it's just the radius of the circle times the angle theta. So if I wanted to know, I was a little fly and I walked from here to here, what would that curve be, that arc? Its length would be r times theta, where r is the radius of the circle and theta is the angle. But here's the kicker. It's the angle in radians. So imagine I gave you, I'll keep that formula separate. Imagine I gave you a question, something like this. We have got a circle of radius 10, and this angle here in radians is 4/3 pi, and we were being asked to find that arc length here. Well, this would be one of the simplest situations because everything we need is here. It's 10 times 4/3 pi. And the answer is 40/3 pi. So if they do not mention, give the answer to 3 decimal places, that means they want the exact value. So that's the one that you will use. Now, if they say give the answer to 2 decimal places, then it's the same calculation. All we do is we take that guy and we find out what he is. So he's 40 pi divided by 3, and say it's to 1 decimal place they wanted, the answer would be 41.9, and let's assume that the units were centimeters. It would be 41.9 centimeters. Are we good with, it's really, here's a formula that does most of the work for us, right? Now, you can be caught out because you might get a question that looks like this. And I'm going to catch you, or try to catch you, in 2 different ways here. The arc that they want is this green one. Right? They want to know that. Now the formula does not change, but there are 2 problems. The first one isn't really a problem. Here is the major problem. What angle should I be using for this question based on the picture that's in front of you here? It's not 100 degrees. 100 degrees would be that guy. Right, say it again. I thought I interrupted.
260.
It is, isn't it? For those who want to imagine where that came from, in case it's out of the blue, it's 260 degrees. Now I'm going to do a mistake. Oh, I got it. It's radius times 260, and the answer is, well, 1300. Let's suppose this is meters. Okay, young lady, that's enough. Time out. There you go. Okay, we're back to square one. What is wrong with what I just wrote? I mean, it's a number. Maybe that arc is 1.3 kilometers long. And would you agree it's highly unlikely based on the size of that circle that going around a circle of radius 5 meters, you'd end up doing 1.3 kilometers. That would be one heck of a race, wouldn't it? What is the problem? What did I do wrong?
You didn't.
Data needs to be in radians.
I didn't do radians. Agreed? Is that what you're thinking, Caitlin? Didn't do radians. Can you see that you need radians and at least conversions? So in this question, don't I have a little side issue? And my side issue is I need to turn this into radians. So here goes. It's going to be 260 over 180 pi. So this formula up here, which we know now doesn't work because the angle I used was degrees and not radians, it becomes 5 times 260 over 180 pi. And I'm not going to make any attempt to make that pretty. I'm just going to do it as a calculation. So it's going to be 5 times, I'll put a bracket around it to be safe, 260 pi divided by 180. And the answer, at least to one decimal place, is 22.7 meters. Does that not seem much more reasonable based on the numbers that are in that picture? If you imagine a circle of radius 5 and you kind of walked that green part, doesn't 22.7 meters at least seem reasonable? A lot more reasonable than 1,300 meters would it? So look at context. If you see an answer and you think, what, that's not right, maybe it's because you did this mistake, right? Maybe it's because you forgot a decimal point somewhere. I guess that could happen too. Any questions about the arc length so far? Okay. Still on arc length, but let's change the puzzle. Let's have a circle. And let me draw a random angle that might or might not be accurate. And I'm going to put the angle theta in here. And I'm going to tell you that this is 5 inches. And the arc length that we're interested in is this arc length here. And the arc length is 12 inches. Only in this question, you're being asked to find the angle theta. So you begin with your formula. You know 12 goes there, you know 5 goes there, and you're trying to find theta. Can you see that you're using the formula, but aren't we using it in a kind of equation kind of way? Aren't we trying to solve for the missing theta? So what do you do to find theta? Or what do you do to both sides?
Divide by 5.
Divide by 5.
I hear you, both of you. 12/5 is good, but they'll probably want them as decimals, or most of these questions are. So what's that, about 2.4 radians? Yeah, not all radians are multiples of pi, right? Oh, that is the answer in radians. Let's pretend they said find theta, but they wanted it to be in degrees. We'd still have to find that theta was 2.4 radians, right? There's no way of avoiding that. But what would I then have to do to get the answer in the units they wanted? I know the answer is 2.4 radians, but how would I convert that to degrees then? What would we do? I think I've made the question harder than it is. What's 2.4 radians in degrees? What do you do to find that answer? I did make it harder than it was. Isn't it
Divide by
degrees?
180.
Yeah, it's that guy. Don't you take this fella and you go, right? So you go 2.4 times 180 divided by pi. In case you need to be reminded, radians 180 over pi, that guy, right? So I got the number in my calculator already, so let's do it. 2.4 times 180 divided by pi, and I get that the angle is about 137.5 degrees. So when you're reading the question, read what do they want the answer to be, radians or degrees or whatever, and what was the information? Did they tell me the angle in the previous question in degrees, or did they tell me in radians? Let's do another one of those puzzle ones. Okay, so there's the arc length that we were interested in. The angle that's here, what will we make that? We'll make that angle 200 degrees. Okay, and we'll make the arc length 100 meters. So we're being asked to find what the radius of the circle would need to be to match this information. Our starting point is going to be r theta. I know this fella is 100. I don't know this guy. But will I put 200 degrees in here? Nope. Won't I turn that into radians like we had to do in one of the earlier questions? So to save myself some time, wouldn't you just do 200 over 180 and stick a pi in it, right? And that would be, oh, let's use a calculator. So it's going to be 200 pi divided by 180, and that is roughly 3.49. So what do I do to find the radius? What do I do next? Do both sides.
Divide by theta.
Okay, so we're going to take 100 and divide it in this case by theta, which is 3.49 radians. And 100 divided by 3.49 is 28.65, at least to 2 decimal places. Now, be careful of rounding off errors. I've been doing everything here to 2 decimal places, but see if the question wants 3 decimal places or 4 or 5, shouldn't you use a lot more digits, even if it's only in your calculator? Because if you round off to 2 decimal places and then wait till you get to the final answer and write it down to 4, do you know you'll be a little bit out because of rounding errors? So if a calculation wants 4 decimal places, make sure that you work at least to 4. If you want to be safe, make all your calculations to 5 and then just round off the last calculation to 4. Any questions about that? Are we comfortable about the various versions of arc length questions that you could get? Okay. Let's show you what some of the homework questions look like then. Because my pictures aren't as neat as probably theirs. Right. So,
I just wanted to ask,
yes.
just in general, so I know I joined a minute late. Am I able to send my name in like at the
Yes,
beginning
you
of
can.
class?
Yes, you
Okay.
can do that. Actually, now that you reminded me, will everybody who hasn't done so put their last name down now for attendance, so that you've got your attendance. Right. Now, here we're first guy. Why has that got the answers? Oh, because this stupid thing's on, that's why. Are you all looking at the arc length homework now? On the right page. Okay, got that. Okay. Can you see this question? the angle is 2/3 pi and the radius is 8, and there you go. Why is that still there? Go away. I mean, Weber sign randomizes the numbers, so even although you can see the answers, you know there's a chance your question won't use the same number, so it'll be different. But it's just annoying to see the answer. That's better. Can you see this question then would simply just be 8 times 2/3 pi and you're good to go? Do you notice that there is no mention of decimal places, which means your answer should be 16/3 pi, right? Nothing but decimal. In later questions, you'll find that they very often do ask, if I can find one, I won't be able to find one, but when they don't mention anything accuracy, you need to do the question in the exact value. Now, look at this sneaky question. Do you see the red S? The angle theta is this angle here, the black one. Isn't the angle we want to use the bigger version of that? So they did one of them and I did one of them with you, right? So won't you have to take that away from 360? Right? Now, if that wasn't bad enough, won't you then have to take the 228 degrees, because that's what you'd get, and turn it into radians before you could use the formula? So you may end up with some really ugly answers like 17/15 pi, right? Because of the numbers. In this question, you know the arc length is 7 and you know the radius is 3. You see how this one wants theta, no mention of rounding off. In this case, you know the angle is 3 radians and you know this is 12. I could do that one in my head. Wouldn't this be 12 divided by 3? Wouldn't this guy be 4? Could almost do that without even doing the work. Okay, now, what do you do if they don't give you a picture? Find the arc length S of an arc subtends at a central angle of measure 6 radians in a circle of radius 7. Doesn't that look like some lawyer got in the way of this question? So if you take out the kind of very, very formal way that we're saying this, isn't the gist of it, you've got a circle whose radius is 7 centimeters, and the angle is 6 radians. Isn't that all you need to get the arc length? Now, this word subtends, that's just the name that they give to, you know, when you open the thing up, the little guy there, that's the angle that subtends is the 2 lines, the 2 arms that make the arc. That's just their fancy name for them. Oh, do you notice that in this, finally, some answers that need to be to 2 decimal places. And find the angle in degrees, which I think is a bit distracting. Won't you actually find this answer first before you get that answer? Don't you always get radians from the formula? And then you turn it into degrees. So I think it would have been much fairer if they put this guy as the first thing to find, and then this guy here as the second thing to find, right? But I think you can live with that. Here's another one of the basic questions written in English. Is there anything about arc length that you want me to talk about? Because that's kind of a natural stopping point for today. Are you comfortable that if we gave you a picture or we gave you, you know, the radius is 3 and the angle's 40 degrees, you could do an arc length? You feel comfortable with those? Then bye-bye. I shall see you tomorrow.
Thank you.
You're welcome.
Thank you.